Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 1.5. It's about elementary matrices and a method for finding A inverse. We will concentrate in how to find A inverse. We studied in the previous section how to find A inverse for a 2 by 2 matrix. We use the formula 1 over determinant A times we change something in matrix A. You can go back to section 1.4. But here we will have a method to find A inverse for any square matrix in general. 2 by 2, 3 by 3, 4 by 4, 5 by 5, whatever. So the method is very simple. You just write the matrix A and the matrix I in one matrix. So for example here, find the inverse of this matrix. So the first step would be to write the matrix A and then vertical bar, and then write the identity matrix. And then we use the row operations we studied in section 1.1, I believe, which we used in Gaussian elimination in section 1.2 to change the matrix A here, to change this matrix to the identity matrix. So when we change A to I, this I will be also changing, and when we get I at the end, we will get A inverse to the right. So I would be to the left, A inverse would be to the right. So that's it. It's an easy method. So to change this to the identity, similar to using Gauss and Jordan, we start by making this number 1. It is already 1, so we use it to make these two numbers zeros. So negative 2R1 plus R2 will change the 2 to 0, and negative R1 plus R3 will make this one 0 using the leading one in the first column. So the new matrix will be, there is no change in the first row. We are using this row to make zeros. So since we have two zeros here, these columns will not change because we are multiplying 0 by any number. It will remain 0 when we add it. It will not change any number below. So negative 2 plus 2, that's 0. Negative 4 plus 5 is 1. Negative 6 plus 3 is negative 3. Negative 1 plus 1, again, a negative 2 plus 0 is negative 2. That's the second row. The third row, negative 1 plus 1, 0. Negative 2 plus 0 is negative 2. Negative 3 plus 8 is 5. Negative 1 plus 0 is negative 1. So now the first column is good. And now go to the second column. This number on the main diagonal should be 1. Well, it is 1, so I use it to make these two numbers zeros. It is the leading one. So to make negative 2, 0, I multiply row 2 by 2 and add it to row 3. And to make 2, 0, I multiply row 2 by negative 2 and add it to row 1. Of course, adding 2 and negative 2 here is not a good idea. You have to use this one to make zeros, because then you will change the first column again. Okay, the new matrix will be the second row here will not change. And since I have 0 here, and I'm using the second row to make zeros, then those columns will not change. Okay, negative 2 plus 2 is 0. 6 plus 3 is 9. 4 plus 1 is 5. And negative 2 here. 2 plus minus 2 is 0. Negative 6 plus 5 is negative 1. Negative 4 plus negative 1 is negative 5. And we have 2 here. And the second column now is good. Now let us multiply row 3 by negative 1. So we have 1. We get 1 on the main diagonal. And it is the leading one on the third column. And now we will use this one to make negative 3 and 9 zeros. So multiplying row 3 by 3 and add it to row 2 will change this 3 to 0. And negative 9 times row 3, add it to row 1 will change it to 0. Now the new matrix will be, now the third row here is not changing. And since these are zeros and we are using the third row to change to zeros, then these two columns will not change. 3 plus minus 3 is 0. 15 plus minus 2 is 13. Negative 6 plus 1 is negative 5. And here I have negative 3. Negative 9 times 1 plus 9 is 0. Negative 45 plus 5 is negative 40. 18 minus 2 is 16. And here I have 9. And that's it. Now we have the identity here. So what is in the right represents A inverse. So now we have A inverse. And you can check your answer if you like, if you have time. The calculator evaluates A inverse. You can check by mode 6. And you can multiply, if you don't have a calculator, A times A inverse. And the result should be the identity matrix. We know that not all matrices are invertible. If the determinant of A is 0, then A inverse does not exist, as we have seen in 2 by 2 matrices. But let us try to find the inverse of this matrix. So we will work as usual. We will see what happens if this matrix has no inverse. So we write the matrix and then we write the identity beside it here. And we use the row operations to change the left one to the identity matrix. So this is 1. Okay, good. So negative 2 R1 plus R2 and R1 plus R3. So the first row is not changing. And because there is a 0 here, and there is a mistake here. Because there are 2 zeros here. So these numbers are not going to change. Okay, negative 2 plus 2, that's 0. Negative 12 plus 4 is negative 8. Negative 8 plus minus 1 is negative 9. And here I'll have negative 2. Add row 1 and row 3. That's it. Now I can go on and try to change this number, divide by negative 8 and make it negative 1. I can do that. But I can see here that negative 8, negative 9, I have 8, 9 here. So if I just add row 2 and row 3 and replace this by row 3, I'll have 1, 6, 4, 1, 0, 0, 0, negative 8, negative 9, negative 2, 1, 0. And I'll have here 0, 0, 0, negative 1, 1, 1 by adding row 2 and row 3. I can make this one, there is no problem, but that's it. After that, I'll not be able to make this 0, 1. So this would be the end. I will not be able to find a inverse. So even if you divide row 2 by negative 8, I'll have 1 here, 9 over 8 here, 1 over 4 or 2 over 8, negative 1 over 8, 0. But I'll have here 3 zeros. So I cannot change this number to 1. So A inverse does not exist. Here, first use theorem 145. This is the theorem we studied in section 1.4, in which we learned how to find A inverse by the formula 1 over determinant A. 1 times 7 is 7 minus 8, so it's negative 1. Let me write it. 7 minus 8. And then 1, 7, we change positions. Or 2, we change signs. So in fact, A inverse is, this is negative 1 multiply negative 7, 4, 2, negative 1. This is A inverse. We know that from section 1.4. He wants us here to use the method in this section, the inversion algorithm, to find A inverse. To check that, we will get the same answer. So let us do it. We have the matrix 1, 2, 4, 7, and let us write identity matrix here and change the left one to the identity matrix. We have 1 here, so let us change 2 to 0. So negative 2R1 plus R2, 1, 4, 1, 0. I have 0 here, so this one will not change. Negative 2 plus 2 is 0. Negative 8 plus 7 is negative 1. Negative 2, I have negative 2 here. Now multiply row 2 by negative 1 to have 1 on the main diagonal here on column 2. I multiply it by negative 1, so I change all the numbers. And now this is 1, make 4 0, negative 4 R2 plus R1. I have 1 0 in row 2, so it will not change this number. Negative 4 plus 4 is 0. Negative 8 plus 1 is negative 7. 4 plus 0 is 4. So A inverse, the conclusion, is negative 7, 4, 2, minus 1, which is exactly the same here. So whether you use this method or this method, but of course, the formula is faster. Let us have a 4 by 4. Okay, let us try to find the inverse of this matrix, 4 by 4. So first, I write the matrix. And the identity matrix, but I4. The main diagonal, the numbers on the main diagonal are ones. This is the identity matrix. Okay. I don't have 1 here. So I have 2 choices, either dividing by 2, it is nice, but I will have 1 over 2 here, or just interchanging row 1 and row 2. Well, I will divide row 1 by 2. Okay. It is up to you, you know. I want to do this. So let me check. So I'll have 1 here, negative 2 here, 0, 0, and 1 over 2, 0, 0, 0, and the other numbers are not changed. Okay. Now I have 1. On the main on the first here. So I'll use it to make the numbers below zeros. They are all zeros except this one. So negative R1 plus R2 will make it 0. So the first row is not changing. And I have a lot of zeros on the first row. So anything below these zeros will remain the same. And here I have two zeros too. Okay, of course, I'm not changing the third and the fourth rows. So negative 1 plus 1 is 0. 2 plus 2 is 4. Okay. And negative half. Good. Now I finished from the first column. Let us change the second column. Well, either I divide by 4, I can divide by 4, or I can use this row, the fourth row, I can interchange row 2 and row 4 and have a 1 here. Okay. So what? Let me divide by 4. So R2 divided by 4. So I'll have 1, negative 2, 0, 0, half, 0, 0, 0, the first row. Second row would be 0, 1. 12 over 4 is 3. Negative half over 4 is negative 1 over 8. And I'll have 1 over 4 here. And then 0, 0. And the last two rows without any change. Now I have 1 here, so I use it to make the other number zeros. I have 0 here, so that's good. So 2R2 plus R1 will make this 0, and R2 plus R4 will make this one, this negative 1, 0. So the second row is not changing. And the third row, because it has 0 here also. Okay. Let me find the last row first because it's just addition. So we are using the second row. So we have 0 here, so these are not changing. We have 0 here, so these are not changing. We have two zeros here, so those are not changing. Okay. Now 1 plus minus 1 is 0. 3 plus minus 4 is negative 1. Negative 1 over 8 plus 0. And 1 over 4 plus 0. Okay. 2 plus minus 2 is 0. 6 plus 0. 2 times negative 1 over 8 is negative 1 over 4 plus half. That's 1 over 4. You can use the calculator to add. 2 times 1 over 4 is half plus 0. That's half. So this is the new matrix. Finished from the second column. Now the third column. I can divide by 2, or also I can interchange row 3 and row 4 and multiplying row 4 by negative 1 and have it here. But I will divide by 2. So there is no change in row 1. no change in row 2. But row 3 would be 0, 0, 1, 0, 0, 0, a half, 0, and the last row as it is. Okay, I have 1 here on the main diagonal. I'll use it to make all of these numbers zeros. That's good. So here I will add row 3 plus row 4. Here I will multiply row 3 by -3 and add it to row 2. Here I'll multiply row 3 by -6 and add it to row 1. Let us see what would happen. So the third row remains as it is. And you can see that it has a lot of zeros. 0 here will keep all of these numbers. 0 here will keep all of these numbers without any change. Also 0 here. Also 0 here. And of course, zeros in the beginning. So 1 and -1 is 0, and this is half. And now -3 plus 3 is 0. And here -3 over 2 plus 0. And -6 plus 6 is 0. And -6 plus half is -3. You add it here. So this is the new matrix. That's excellent because finally we have only what is remain is to change this to 1, and it's easy to change it to 1. The only way here is to divide by -5 because there is nothing below this row. So the final step, all of these rows without any change. Also the third one. Now the last one. 1. -1 over 8 over -5. It would be 1 over 8 times 1 over 5. It would be 1 over 40. 1 over 4 over -5. You can use the calculator. It would be -1 over 20. Half over -5. It would be -1 over 10. And 1 over -5 or -1 over 5. And finally, we have A inverse. And as usual, we can check that this answer is correct by multiplying A times A inverse. Also, there are calculators on the web. You can say inverse, matrix inverse calculator, for example. And you put the matrix and he will just calculate the inverse for you. This was the last example in this section. I hope you got the main idea, which is one idea only in this section. Have a nice day.